All right, everybody. So you guys can see that yesterday we studied numbers in detail. हमने numbers को कल detail में पढ़ा है, and along with that we tried our level best to have the better understanding according to the syllabus. And we stopped here. And yesterday we studied natural numbers, integers, prime numbers, common factors, common multiples, reciprocals, and we studied the prime factorization thingy last day. And today I'm going to proceed the lesson now. So please pay attention, everybody, because every lecture is important. So this is our lecture number 2, and this is our lecture number 2. So I'm making notes for all of you. So if you guys are just revising, so just listen to me very carefully. That's lecture number 2, right? So yesterday we discussed about the factors and the multiples, and you get 1 mark question or at least 2 to 3 mark question on factors on multiples on both of them. Like for example, examiner can ask you write factors of write factors of 36. So it means that you have to tell the examiner that 36 comes in how many tables. So it means that what is the meaning of this question? The meaning of this question is in 36 comes in how many tables? How many tables? So you have to see till 36. So start from table 1 always. So table 1 times 36, 2 times 18, 3 times 12. Yes, 3 plus 6 is 9. 4 times 9. See, we are getting closer. And then 6 times 6. So tables repeated. So you can get this question in the examination. So the factors of 36 are factors of 36. It is equals to 1, 2, 3, 4, 6, and then 9, then 12, then 18, and then 36 itself. So remember one thing, the bigger factor of a number will be a number itself. So 36 cannot have a factor greater than 36. Keep that in mind. Okay? I'm going to explain that thingy in a minute as well. Like for example, and if you get a question, and this is a question that can come in a non-calculator for 1 mark at least. So they can ask you that write first 3 multiples of 7. So better do not get confused. Examiner say write down first 3 multiple of 7. So the first multiple of 7 is 7 itself. So you cannot write 14, 21, and 28. You will lose your credit here. First 3 multiple of 7 means that table 7. The examiner is asking you about table 7. That's the hint in the question. So the answer would be the first 3 multiples of 7 are 7, 14, and 21. That is what the requirement of the question is. I hope all of you got the idea. Yes or no? Well done. Good job.
जी सर।
Thank you. Okay, everyone. So I'm allowing you to chat with everyone. So your chat will be watched by everyone. So please use appropriate language in the chat box. And this is important for a very good disciplined class. Okay. Okay. Now, guys, it's time to understand something. Better remember one thing. For example, if this is a number. So sign we discussed that earlier as well. Agree? That numbers will have the multiples on the right side and the factors on the left side. Yes.
जी
So the right side will be multiples and the left side would be factors. Agree? So remember one thing, what I'm just saying to you, I'm just saying this to you, like for example, 36 is a number. So you can see that the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. So you can see that the factors of a number will always be less than a number including a number, and multiples of a number will be including that number, and it will be greater than that number as well. So it's 36 double is 72. 72 plus 36 is 108 if I'm not wrong. And 108 plus 36 is a 7144. Yes, and up to so on. So remember one thing, a number, a number a number can be a factor or multiple of itself. Got the idea, everyone, or not? Yes. Like that, that's a very common mistake in a Cambridge exam, that sometimes the examiner is asking you write down the factors of 8, and you guys just write down 2, 4, and 8. You guys just simply skip one. So you cannot skip one. If the question is write down all the factors of 8, so you have to tell the examiner that what are all the factors of 8. That is very much important for all of you to understand this thing, okay? So I hope the
सर
concept.
फैक्टर्स ऑफ 8 में 8 खुद आएगा.
क्यों ऑब्वियसली आएगा, क्यों नहीं आएगा? मैंने अभी आपको ऊपर क्लियर किया दैट अ नंबर कैन बी अ फैक्टर और अ मल्टीपल ऑफ इटसेल्फ. वो अपना फैक्टर भी हो सकता है और मल्टीपल भी हो सकता है, क्या रे? Okay.
ओके
Now
सर.
we are proceeding towards the prime factorization. So remember one thing, yesterday I started it, but not in that detail. So please just pay attention. So just remember one thing, that I'm going to start now prime factorization. So the concept of the prime factorization. This is important in the examination. We always have one question in both the syllabuses, IGCSE or whether O levels. So prime factorization. So please pay attention, everybody. So prime factorization is technically dividing a number only by its prime factors. It means that a prime factorization is a type of a concept in which you will be dividing a number only by its prime factors. So it means that, let me write this in English as well. Dividing a number only by its prime factors. For example, if the question is find the prime factors of 84. So better remember one thing. If you want to find out the prime factors of 84, it means that you have to divide 84 by prime factorization. Okay, so now remember one thing. We have always have this tier method, and you guys must have studied this in your school as well. So 84. So now remember one thing. Yesterday we discussed that prime numbers are those numbers which comes in their own table. Okay? So now you can see that 84 is an even number, so it can be halved. Yes. 42 is again an even number, so let's use 2 again. So 21. I know that 21 can be divided by table 3 because 2 plus 1 is 3. So 3 sevens are 21 and 7 ones are 7. So it means that 84 is a number, integer, and this is 2 square times 3 times 7. So what is this on the left side? Left side is technically in an integer in front of you, integer. Okay, and the right side is technically, what this is technically, the prime factorization of 84. Prime factorization of 84. Factorization of 84. Understood, everybody, or not? Yes or no? Any problem so
Yes,
far?
sir.
Okay, that's good. Okay. Proceeding to the next part of this chapter, because this chapter is technically easy chapter and most of you must have studied this chapter in your schools. And now we have a question always in exam, which is LCM and HCF. We have multiple techniques of finding LCM and HCF, but I prefer one of the technique, which is highest common factor is write common only, and the least common multiple is take highest powers of all. What is this all about? Let's just see the question. Okay. After prime factorization, we are going to move towards LCM and HCF. So let me just set the paper. Okay, the paper is set now. Okay, so it's the concept of LCM and HCF. So just remember one thing, least common multiple and HCF. We saw that one thing, that when we were finding 36 factors, it was a very difficult job to read the table till 36. And when we were finding the multiples of 36, it was very difficult to read the table of 36 because we do not know the table of 36. We can just simply add it with the help of a calculator. Now remember one thing. For example, you have to remember this fact, whatever I'm going to write here. So please pay attention. And in LCM and HCF, that would be your hint for the chapter. Hint for the chapter. So hint for the chapter is in LCM and HCF, do prime factorization. Apologies. In LCM and HCF, do prime factorization. If it's not available, if it's not, do prime factorization of the numbers given, numbers given. Okay. For HCF, write common only, common only. And for LCM, take highest powers of all. Apologies. For example, the question is find the LCM and HCF of 36 and 84. So let's follow the steps. Step one is in LCM and HCF, do prime factorization of the numbers given. Okay, let's do it. So let's do the prime factorization of HCF 36. And let me write this 84 again. Okay. So half of 36 is, okay, guys, you can start from 3 as well because it's a prime factor. But you can, in that area of the prime factorization, you cannot write anything other than the prime number. So remember that thing. अच्छा इस चीज को याद रखना ठीक है, that is very much important ठीक है. Okay, so we know that I can half the 36, half of 36 is 18, half of 18 is 9, and 3 threes are 9, and 3 ones are 3. Okay, that's fine. 84 can be half 42, 21, 3 times 7, and 7 times 1 is 7. Okay, now guys, we got the idea that 36 it is equals to 2 square and 3 square, and 84 it is equals to 2 square times 3 and 7. Okay, I want to find out the HCF and LCM of these two numbers, so I wrote a hint for you above. Can you please see that? And I hope all of you can see that very clearly now. HCF is right common only, right common only. Okay, let's see. Guys, can I say that 2 squares is common in both of them? Yes, 2 square is common in both of them or not?
Yes, sir.
Okay. Can I say that 1, 3 is common in both of them because 36 is having 3 square, but 84 is having 3 only? Yes?
Yes.
So 7 is not common in both of them. So it means that 2 square times 3 is my answer. So 2 square is 4 and 4 threes are 12. So HCF, the highest common factor of 36 and 84. 12 is the highest number that can divide 36 and 84 completely. Remember that. Is this clear? Okay. And now we are proceeding towards the LCM now. So LCM is what? Right highest powers of all, right? Highest powers of all. Guys, just see this. I have 2, 3, and 7 in both of them. So I'm gonna write here. Zara. Can you see me? So I can see one thing here very clearly, mera bacha, that I have 2, 3, and 7 available in both the prime factorizations. So I'm writing 2, 3, and 7. And guys, the highest power of 2 in both the cases is 2 square. Yes. So the highest power of 2 is 2 square. Highest power of 3 is 3 square. And the highest power of 7 is 7 itself. It means that this is what my answer is. So it means that 2 square is 4, 3 square is 9, and 9, 7. 4 nines are 36, and 36 times 7 is how much? Can anyone help me out with the multiplication? 36 times 7 is equals to multiplication. 7 6 sevens are 42. Okay, so 7 threes are 21 plus 4 is 215. 21 plus 4 is 25, sorry. That's 252. So better the LCM of these two numbers is 252. That's how we can easily find out any LCM and HCF if you know this method. Remember one thing. I know that books and the teachers in the school, they always teach loop 1 and loop 2 method as well. But loop 1 and loop 2 methods, they are easy, but they can be applied in few cases, not all the cases. In this question can be solved with every case. Like for example, I'm going to give you another question right now in front of you. Please just watch. We will be skipping step 1 and we will be proceeding. We will be finding HCF and LCM in a very quick way. Just give me a second, okay? So guys, please pay attention. For example, just look at question number 2. Question I'm going to write here in front of you. Question is in front of you. So that is my question number 2. Guys, please pay attention. But a p is a number having 2 cube times 3 times 5 square times 7 times 11. So it's a very big number. Agree? And q is a number which is, let's suppose, 2 power 5, 3 square, 5 and 7 square, and this is 11 square. So guys, listen to me very carefully. And the examiner can ask you, find out the LCM of an HCF of P and Q. So guys, remember one thing that Sarbasa told you, that what is the method? Just remember this sentence. For HCF, just write this sentence in English. In your exam paper, write common only. You will get the idea that how to solve this question. You got the idea that 2 cube is common in both of them, because one of the q is having 2 power 5. It means that this 2 power 5, it has 2 cube already. So I can write 2 cube common. I can write 3 common because 3 square is having 3. Okay, I can take 5 common because 5 square is having 5 common. Okay, I can take 7 common. Oh yes, 7 is also common. And I can write 11 common as well. So see, it's a very big number, and examiner will not demand you to expand this number, and this is what your final answer is. But if you want to write the answer for the LCM, so just write the sentence I told you. LCM is what? Take highest powers of all. Take highest powers of all. Powers of all. So guys, can you see that we have 2, we have 3, we have 5, we have 7, and we have 11 numbers. These are the integers which are present in the prime factorization of these two numbers. So highest power of 2 is 5, highest power of 3 is 3 square, highest power of 5 is 5 square, highest power of 7 is 7 square, and highest power of 11 is 11 square. So it means that that is what my final answer is. It can be applied in every situation. Now, for example, in a question like that, you cannot apply that loop 1 and loop 2 method. Is this clear, everyone, or not? Yes or no?
Yes.
So this is the best way to find out the LCM and HCF of any number. Got it, everybody? So that's how we can easily proceed with the chapter as well. So I hope all of you do not have any questions related to LCM and HCF. I am proceeding towards the prime factorization signals of the prime factorization. So please pay attention. There are two signals that prime factorization can give it to you, and that can be asked in the paper for a 1 mark. Signals by there are some signals by prime factorization. First signal is square number. First signal is square number. So the first signal given by the prime factorization is a square number. So remember one thing: if the prime factorization powers, they are in multiples of 2, so remember that that number would be a square number. Like for example, what I'm saying here, just please pay attention. If prime factorization if prime factorization have powers in multiples of 2, so that's square number. So that's square number. For example, P is a number. It's 2 square times 3 power 4 times 5 square. Is this a square number, guys? Yes, it is a square number because all the powers are in multiples of 2, as all the powers are multiples of 2. So P is a square number. Understood, everybody, or not? And the second signal given to you would be a cube number. So it would be same, everything will be same, but just for multiples of 2, it would be multiples of 3 now. So I'm not going to waste my time. Let me just copy each and everything, and I will just add it something. So just give me a second. Okay. Apologies, bacha. Okay. Stroke eraser. Okay. So guys, in a cube numbers, remember one thing: if the prime factorization have powers in multiples of 2, no, it should be in multiples of 3. In the cube signal, okay, it should be in the multiple of 3. So you can see that. Let me change this number now. So if P is, for example, 2 cube times 3 power 6 times 11 power 6. So you can see that as all the powers are multiples of 3, so P is a cube number. So P is a cube number. I hope this is clear to all of you. Yes or no? If the powers in the prime factorizations, they are multiple of 2, so it's a square number. If a powers they are in a multiple of 3, it's a cube number, but a number can be a cube and a square number at the same time, because you can see one thing, like for example, as you know, as for example, q is 2 power 6 and 3 power 6. Yes, 6 is the multiple of 2 and multiple of 3, so I can say that q is q slash square number, both at the same time. And we are familiar by 64 because we know that 64 is 8 square, but 64 at the same time is technically 4 cube as well. So if q is a cube number, q is a cube number and a square number at the same time, because the powers in the prime factorization are multiple of 2 and multiple of 3 at the same time. So please, I hope the concept of this question is clear to all of you. Yes or no? Agree everybody or not? Yes. Any problem so far? Any problem?
No, sir.
Okay. Proceeding. These are the signals given by the prime factorization. Okay, now we are technically done with this chapter, but we have to understand about the time value, and the time value of what the standard form, because we know that in mathematics we have a scale, and the scale that can be tested in your exam is still billions. Okay, so scale, remember that. Okay, always. Better scale is ones, tens, hundred, comma, thousand, 10,000, 100,000, million, 10 million, 100 million, comma, billion. Okay. So better that's the scale examiner can ask you for 1 mark in your paper. That scale can come in a 1 mark, and examiner can ask you 2 questions in that. For example, question number 1, write 6001237 as in words 0 in words. But do not be ashamed that you don't know this. Now it is the right time to understand this. Now just the technique is, because you will be having for example guys, you will be having this much space at least available in the paper. This much space will be available in the paper. So how to do it? Just write the number with some distance between them, like this. I'm not going to do another example on that, so please pay attention. Start writing commas, but start from the right side. After every 3 digits, write the commas. Okay. Now write the scale, whatever is written above. Shukr. Ones, tens, 100,000, 10,000, 100,000, million, 10 million. So guys, I have to start my scale from million. So it's 60 million. So this is 60 millions. Okay. In thousand place, you can see that it's only 12,000. So 60 millions, 12,370. That is the answer. Okay, just for the sake of understanding, if you are just saying that 60 million, so you can write a comma after 60 million, 12,370, and write a full stop after that. Okay, it's not an English exam, so you have to be. So will question like this come in the exam? Yes, you will get 1 question on the basis. You can have 2 questions on the two styles. One is from writing from number to words, and one can be from words to numbers. Like for example, you can get a question like this in a paper. The second style of the question can be that write 18,007 as integer. Now you got the idea. It is 18,007. So most of the students, they will uh, make a mistake here. So you have to write the scale till 10,000 because it's 18. 18 is 10,000. So you have to write the scale ones, tens, 100,000, 10,000. So it's 18,000. 18 will come here. Okay, so it is and 7, so two zeros will come here, and that's the 7. So that is what your final answer is. If you write 1807, that is 1807. If you write the 18700, that is 1800, 700. So remember one thing, these little 1 mark questions, they are gonna give you an A grade at least in your math examination. So do not skip those things, please. This is very much important. I told you guys yesterday that you have almost 1 month left. Sorry, 5 months. So you have 5 months. And 5 months, they are very much good enough to make your preparation for an A star grade. Okay? So that's done. So let's see, according to the syllabus, what is left. Let's see. So we have done everything. Now let's talk about some square and cube numbers and rational and irrationals, and then we are done. So better in Cambridge examination, remember one thing that you should be tested about some memorizations, and that memorization is the memorizing the cube and square numbers. So memorization of cubes and and square numbers is tested in the exam. So how many we should memorize? So square numbers, first 15. Square, first 15. You should memorize. So we know that. I'm gonna write this for you. So let's start getting in your room. Okay. So 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64, 9 square is 81, 10 square is 100, 11 is 121, 12 is 144, 13 is 169, 14 is 196, and 15 is 225. So that is first 15 square that you have to memorize before examination. And the formula for the square sequence is n square always. And we have a cube numbers as well. So how many cube numbers that can be tested in a non-calculated paper, because it is written in a Cambridge exam syllabus that you have to memorize these. So cube numbers only first 10. So first 10, so 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is 125, 6 cube is 216, 7 cube is 343, 8 cube is 512, 9 cube is 729, and 10 cube is 1000. And with the help of some memorization techniques, you can easily ace this particular topic. And just remember one thing, this is an easy topic, and you all just need is my these two classes session, and then you are good to go for the practice. Okay, don't you worry about that. We're gonna do practice on as well after this. So we are done with the square and cube numbers, and now we are left with only rationals and irrational numbers. So that question is always the part of the paper. I'm not talking about the rational numbers, I'm talking about the irrational numbers. Okay. So just remember one thing. As we know that the concept of rationals and irrationals, so better remember one thing. Rationals are rationals are technically what? They are technically teacher will there will be a question in exam where they will ask us to list down the square numbers and cube numbers. Yes, they can be. They can ask you that write down the first pick a square number from the list. If you do not have memorized that, so you cannot pick that. So remember that, okay? Rationals are those which can be which can be written as fractions. Let me give you some examples. Guys, I can write 0.2 as a fraction, that's 2 by 10. 1 over 2 itself is a fraction, so this is not rational. Agree. Square root of 4 is 2. Yeah, that is rational. Square root of 9, that is rational because it's 9. Agree. Square root of 16, that is rational because they can be written in a form of a fraction. Because remember one thing, if you write 2, so 2 means what? 2 means 1 over 2 or 2 by 1. Yes or no? So it means that that is a fraction. Remember one thing, irrational numbers are those. So is square 64 rational? Yes, obviously, because square root 64 is equals to 8. Irrational numbers. Okay, that is tested regularly in the examination. Irrational numbers. cannot be written in a form of fractions. You cannot write irrational number in a form of a fraction. For example, the examples for the irrational numbers are, these are technically, the hint is just write the square root. Don't write any perfect square in it. So don't write any perfect square. So that is what an answer is. Like for example, so irrational number, irrational numbers between 1 and 10, between 1 and 10. So beta, irrational number between 1 and 10. Sorry guys. So it's a square root. So let me write all of them. Square root 2, square root 3, square root 4, square root 5, square root 6, square root 7, square root 8, square root 9. So irrational number between 1 and 10, I wrote everything. Now remember one thing. Square root 4 is out because square root 4 is equals to 2. Square root 9 is out because square root 9 is equals to 3. So remember one thing. So the irrational numbers are square root 2, square root 3, square root 5, square root 7, square root 8, but not square root 9. Okay, understood everybody or not? Yes? Done? Done?
Yes.
Any problems so far?
Yes, sir.
Sir,
So we are technically done with this particular topic, and that is the syllabus in front of you. Yes, you can see that. Alhamdulillah, we started this yesterday, and we are done with the conversion of the currency now, and we are done with the words. We are done with the find the HCF of two numbers and find the LCM of two numbers that are written in the syllabus. We are done with square numbers, cube numbers, rational and irrational numbers. I took this screenshot from your syllabus, so you can also check and cross check as well whether something is left or not. Okay, everyone. So done. Any problem, Ji, so far? Ji?
सर ये इरेशनल नंबर हमेशा स्क्वायर में होगा?
स्क्वायर रूट में होगा बेटा, ठीक है, मैंने आपके लिए हिंट लिख दिया है, स्क्वायर रूट। डू नॉट राइट, डोंट राइट एनी परफेक्ट स्क्वायर, कोई भी परफेक्ट स्क्वायर बीच में मत लिखें, इरेशनल है, ठीक है। एनी प्रॉब्लम?
No.
Okay, guys, see that, let's open something in your for example, most of you will have the MS past paper booklets. Let's see that whether we can attempt any numbers question on that as well. It's O levels paper 1, and it's types of numbers. That's our first topic. Let's see what questions do we have in particular paper. Let's see that whether we can attempt this paper or not. Okay, let's see. This is question number 1. Express 36 as the product of its prime factors. So 36 as the product of its prime factors. So we have to do the prime factorization as I told you. So 36 can be halved, yes. 18, 18 can be halved, 9, yes. And 3 threes are 9 and 3 ones are 3. Aisha, my answer is 2 square times 3 square. It is saying that 36 is a square number, and we know that 36 is 6 square. Agree?
जी sir.
Okay, write down two prime numbers whose sum is 15. Okay, two prime numbers whose sum is 15. So beta, I know that 1 plus 14 is 15, but 14 is not a prime number, and 1 is even not a prime number. 2 plus 13 is 15. Yes, both of them, they are prime numbers. So 2 and 13 is the answer. Yes or no? Yup. Easy peasy. Easy peasy.
Lemon squeezy.
Yeah. Okay. Write 54 as the product of its prime factors. So let's write 54 as the product of its prime factors. So half of 54 is 27. 3 times 9 is 27. 3 threes are 9 and 3 ones are 3. So the answer is 2 times 3 cube. That is my final answer for 1 mark. They say that find the smallest possible integer such that 54m is a cube number. Okay, 54 m should be equals to a cube number. Now remember that signal, okay? That cube number signal, okay? Cube number. Okay, guys, I have 54 in this particular question, and 54 can be written as 2 times 3 cube, and that's m. Yes or no? If I want to make this a cube number, I need powers multiples of 3. Do you agree with me or not? Yes or no?
Yes.
Yes, I need powers multiple of 3. I have 3 cube. 3 cube is perfectly a cube number, but 2 is not a cube number because 2 is having only 1. I need 2 more 2's. So it means that 2 times 3 cube should be multiplied with a 2 square to get this 2 cube and 3 cube. And that 2 square is technically what? It's technically your the value of m. Yes or no? This is your value of m.
एक मिनट सर
That is our signal. So m2 square is 4. So the value of m is equals to 4. Now Ayan, अगर आप 54 को 4 के साथ मल्टीप्लाई करें तो 216 आएगा और अभी मैंने लिख के बताया था कि 216 is a cube of 6. Yes or no, everyone?
Yes.
Everyone, is the concept clear? Yes, I can repeat. Just give me a second, okay? Okay. Now remember one thing, examiner is saying find the smallest integer m such that 54m is a cube number. Remember that signal that prime factorization can give you. I can see this prime factorization. This is not a cube number. In order to make a cube number, you need 2 more 2's. Do you agree with me or not, Maria?
Yes.
So that 2 square is your m. So that's what I wrote here. Any problem, G?
No.
Okay, that's very good, mashallah. Okay. Now proceeding, write down an irrational number which has a value between 4 and 16. Okay, guys, we know that irrational numbers are in square root, and we know that square root 16 it is equals to 4 and square root of 25 is equals to 5. Yes or no?
Yes.
So write anything from square root 17 till square root 24 that will be having the value between 4 and 5. So you can write anything from square root 17. So you can write anything, anyone from square root 17 till square root 24 because they are technically irrational numbers. Agree everybody or not?
Yes.
Now Arfa Kufi is using number cards to form a 5-digit number and his number is a multiple of 8. Okay, that's fine. Multiple of 8 means that this number will be divided by 8. Do you agree with me or not, everyone? Yes?
Yes.
Okay, so we know that 8 ones are 8, so 8 ones are 8, and this 4 will go there. Yes or no? Because it's 12, and 43 is not the member of table 8. I know that 8 fives are 40, so 3 will go there. 34 is not the member of table 8. 8 table has 32, so 8 fours are 32, so 2 will go there. I know that table 8 should have 2 something. So now we know that 8 ones are 8, 8 twos are 16, 8 threes are 24. So the last digit is 4 definitely because I need to divide this completely. Yes or no, everyone? Any problem so far? Because if you write 6, 26 is not the member of table 8. If you write 28, you cannot write it because 28 is not the member of table 8. If you write 0, so 20 is not the member of table 8. So the last digit in this particular question is 4. G. Understood everybody or not? So it's a 1 marker question. So it's done, dusted. Okay. Sir, can you explain part B again? Yeah, I can. Can you see that Kofi is using, I'm repeating the question, so please pay attention, everybody. Kofi is using a card number to make cards to form a 5-digit number. 4 of the digits are in front of you. His number is the multiple of 8. Multiple of 8 means that this number can be divided. This number can be divided by 8. Is this clear to you, Zainab?
Yes.
Okay, now we have to check that whether it can be divided or not. We know that 8 ones are 8, so 8 ones are 8, and 12 minus 8 is 4. 43 will come. Yes or no?
Yes.
8 fives are 40, so 3 will go there. 34 will come. Yes or no?
Yes.
Table 8 has 32 and 8 fours are 32, so 2 will go there. Yes or no?
Yes.
So I know that 8 ones are 8, 8 twos are 16, 8 threes are 24, so it is 2, so let's write 4. That last digit is 1, 2, 3, 4, 4 is a multiple of 8. Got it?
Okay, thank you.
My pleasure. Okay. Proceeding, everybody. Question number 4, please. Question number 4, the prime factorization of 120 is given and expressed 1200. So we can see that 120 times 10 is 1200. Yes or no? So no need to do prime factorization again. We know that 120 times 10 is what? 1200. So can I say that 1200 is equals to 2 cube times 3 times 5 times 10? Can I say that or not? Yes or no, everybody?
Yes.
Can I change 10 into 2 into 5? Because 10 is not a prime number. So can I write 1200 as 2 cube times 3 times 5? And in place of 10, can I write 2 and 5? Uh-huh. Yes?
Yes.
Okay. So can I write that 1200 is equals to 2 power 4 times 3 times 5 square? Can I write like that or not? Yes or no?
Yes.
So the prime factorization of 1200 is 2 power 4 times 3 times 5 square. That is final answer. Now you can see one thing, Ayan, that this is giving me a hint that 2 power 4 and 5 square is a square number, but 3 is not. So this is not a square number. Agree? Whatever that number is. And we know that 1200 is not a square number. Agree? Again, you can see that, Shireen, that find the smallest value of n such that 120n is a square number. Remember that signal. Agree? 120n is a square number. So guys, 120n is square. So in place of 120, I'm writing the prime factorization which is given to me in a question. Any problem, guys, or not? Yep.
No.
Beta y power 4 because it's 2 cube and that's 2. So 2 cube and 2 will make 2 power 4. Right, Maria? Okay, now I want to make this a square number, so power should be multiples of 2 now. So 120 is written as it is, guys, 2 cube times 3 times 5. Guys, I'm writing something to make it as a square number. In place of n, I can write one more 2 so that it is 2 power 4. I can write one more 3 so that this is 3 square, and I can write one more 5 to that it is 5 square. So yes, now this number is what a square number, because it will give you technically what 2 power 4, 3 square and 5 square. And yes, this box is technically your n, the value of n. Any problem, G? So what that n is, 2 threes are 6 and 6 fives are 30. So 30 is the answer. So it means that, Ayan, if you multiply 120, if you multiply 120 with 30, you will get a square number.
सर
Sorry.
ये टू क्यूब ये अकेले टू के साथ प्लस हुआ है तो इसलिए 4 आया है ना
Yes, obviously, sir. बेटा 2 क्यूब मल्टीप्लाई बाय 2, 2 पावर 4 हो जाएगा ना जी. क्लियर एवरीवन और नॉट?
Yes.
Okay. Now evaluate 60 square root 64, it is equals to 8 if you know the perfect squares. And cube root of 125, it is equals to 5. So 8 minus 5 is equals to 3. That's done. Square root of 64 is 8 and cube root of 125 is 5. It is only done only if you memorize that. Find the fraction that lies exactly halfway. So remember that, guys, halfway is technically add them and then divide by 2. So let's add them. So 3 over 5 plus 3 over 4. So you can use the butterfly method and you can use the denominator comparison as well. So you can multiply this side with 5, this side with 4. So 4 threes are 12 divided by 20 plus 3 fives are 15 divided by 20. That is 27 divided by 20. That's add them. Now divide by 2 as well. Okay, find the fraction. So 27 divided by 20 divide by 2. Divide by 2 means that 27 divided by 20 multiply by 1 over 2. So the answer is 27 over 40. And this question came for 2 marks in a Cambridge examination. Yes or no? Easy peasy. जी. Okay. Question number 7 is 168 as a product of its prime factors. So 168 prime factorization. So let's do that. 168 as a product of its prime factorization. So 2. So it's 84. Half of 84 is 42. Half of 42 is 21. 3 times 7 is 21. And 7 ones is 7. So my answer is 2q and 3 and 7. Okay, so that's for 2 marks. It's easy. HCF of 168 and N is 42. Now your knowledge will be tested. Please pay attention. HCF of two numbers 168 and N. You have HCF given, which is equals to 42. I'm interested in 42 prime factorization. The prime factorization of 42 is 2 times 21, and 3 now, not 2. 3 times 7 and 7 ones are 7. Okay, guys, HCF is 42, which can be written as 2 times 3 times 7. Guys, I have the prime factorization of 168, which is 2 cubed times 3 times 7. Yes or no? Agree? Agree?
Yes, sir.
Now, please pay attention, everybody, to find out the value of n. You need to remember what I taught you in the beginning of this lesson, that HCF is what? Right common value, right common only. HCF is what? Right common only. It means what? It means n is having 2 times 3 times 7 for sure. Agree? Yes?
Yes.
So I can write 2 times 3 times 7 for sure. Now, given that we know that 2 times 3 times 7 is 42. Given that n is greater than 200 but less than 300, find the possible values of n. So now remember one thing. If I just simply write this, and just please pay attention, everybody, I want to make it common, and it should be 2, 3, and 7 should be common. 2, 3, and 7 should be common. So let's write n1 and n2, two values of n. Okay, guys, 2, 3, and 7 must be there. 2, 3, and 7 must be there in n and n2. Okay. Now, guys, we know that 42 is technically, the 42 times 10 is 420. So half of 420 is 210. So technically, I have few multiples of 42 available in this particular range. And that multiples of 42 are technically in front of you. 42 multiples are 42. 84. Let me just try to get this idea that how you can do that. 42 ones are 42, 42 twos are 84. If I add 42 with it, so it would come 84 plus 42 would be 6, and plus 4 is 126. Yep. Let me add 42 once again. If I add 42, so this will become 8, and if
168.
I add 40 to 168. If I add 42 one more time, so that would be 210. If I add 42 one more time, that would be 252. If I add 42 one more time, it would be
202.
294. 290. 42 plus 40 is 294. Yes. So guys, can you see that the value of n can be 210, it can be 252, and it can be 294, but it should not disturb your HCF. Keep that in mind. You cannot change 168, you cannot change the HCF, you can change the number only. Is this clear, everyone, or not? Yes? Yes?
Yes.
Okay. So let's do that. लेट मी राइट आई कैन नॉट चेंज टू गाइज मैं टू को चेंज नहीं कर सकता ठीक है क्योंकि अगर मैं टू को चेंज करूंगा तो टू स्क्वायर कॉमन हो जाएगा एग्री और नॉट एवरीबॉडी आई कैन नॉट चेंज टू सो लेट मी चेंज 7 and if I write one n value as 7 square, so still 7 will be common. Do you agree with me or not? Yes or no?
Yes.
And another value will be changed by 3 square only. Get it? Get it?
Yes.
In one value of n, I change 7 square, and in another value of n, I change 3 square. So if you just simply just check it, so this is technically 2 3s are 6, 6 7s are 42, and 42 times 7 is 296. 42 times 7 कितना आया था? 294 आया हुआ है. कितना आया हुआ बेटा? 294. And 42 times 2 7s are 14, and 14 times 9. So what is 14 times 9? What is 14 times 9?
136. No,
Okay, that's
126.
okay. That's not the point.
126.
Okay, it's not accurate now. I have to change. 136 is less than 200. So let me make this as 2 cube now. 3 cube. Let me make this 3 cube now. So let's check now. 2 times 27, because 3 cube is 27. So 2 times 27 is 54, and 54 times 7 is 54 times 7 is, हमें दूसरा value of n भी निकालना है.
378 शायद.
What?
378.
Okay, that is also wrong. ये भी गलत है. तो हम लोग अभी दूसरा चेक करेंगे जी. अभी दूसरा चेक करना है हमें इसको चेक करना है क्योंकि we need the value of n between 200 and 200 and 300 and there are three values and I'm allowed to write only two whose HCF cannot be changed. Yes or no?
Yes.
I got one value as 294. I got one value as 294. That's for sure. That is fine. No problem. Okay. How can I get another value of n and without not disturbing? Let me just erase this 2 square. मैं जरा ये 2 square यहाँ से erase कर देता हूँ. Okay, let me just change this another value of n. Okay, my HCF remains same. So it is having 2, 3 and 7. So let me change some powers. Agree or not? Yes?
Yes.
Okay, but I cannot change the power of 2. Remember that. If I change the power of 2, so my HCF is gonna change and that's what I do not want. Agree?
Yes.
Okay, so can I write 5 here? Because 42 times 5 is what? 42 times 5 is what?
210.
Yes, that's 210. Agree or not?
Yes.
210.
That's 210. Still, you can see that the value of n1 and n2 will have the same HCF with 168. Yes or no?
Yes, sir.
Agree or not? If you have 294 or 210 written with 168, you will still get the HCF 42. Agree?
Yes.
So that's enough for today. Thank you so much, everyone. Inshallah, see you tomorrow. Tomorrow, I'm going to start sets and Venn diagrams. So do practice this topic today at home. Good luck. Take care. Bye-bye.
Allah Hafiz, sir.
Allah Hafiz. Thank you.
Officer.